Welcome to this explainer. Today, we're diving into something absolutely essential for modern software development. Think for a second about building a high-performance sports car. You wouldn't just slap a bunch of parts together, start the engine, and then literally never look under the hood again, right? Of course not. You need an incredibly precise assembly line to build it in the first place, and then you need a routine, meticulous maintenance schedule to ensure it actually keeps running at peak performance. Well, software development is remarkably similar. In this explainer, we're going to explore two practices that act as that flawless assembly line and that vital maintenance routine: continuous integration and code refactoring. But before we get to the solutions, we have to ask a pretty important question. How on earth do development teams build complex software without it descending into total chaos? If you've ever been part of a fast-moving project, you know the real-world nightmare I'm talking about here. Broken software, overlapping code conflicts, endless bugs, and the inevitable team friction that comes right along with it. When multiple developers are trying to write and merge code at the exact same time, things can and will break hard. But thankfully, we have some automated saviors to rescue us from this mess. Okay, let's dive into this roadmap. First, we'll look at the automated assembly line, which is CI. Second, we'll cover CI benefits and some top tools. Third, we'll move into the vital routine maintenance with the art of refactoring. Fourth, we'll talk about overcoming developer friction. And finally, we'll wrap up with the ultimate payoff. Section 1, the assembly line. CI, automating the build process. To start off, let's establish exactly how we construct complex software without breaking it. What exactly is continuous integration? Widely known just as CI, it's a DevOps practice that focuses on frequently merging code changes into a shared repository. And crucially, it involves testing those changes at the absolute earliest opportunity. You can think of CI as a hyper-efficient assembly line. By integrating new code changes and adding features seamlessly, it wildly improves team communication, tracks changes perfectly, fixes bugs early, and heavily reduces those dreaded conflicts in the codebase. And this brilliantly illustrates the loop in action. This continuous integration process relies on a strict 5-step sequence. It kicks off with planning, which leads right into coding. From there, we move to making changes or merging that code, immediately checking the results, and finally pushing it out. It's a continuous, repeating cycle. It ensures that every single piece of code is scrutinized and validated before it ever has a chance to break your larger system. Moving on to Section 2, CI benefits and top tools. Let's see this engine at work. Incorporating CI into an agile environment provides massive, tangible benefits. First up, it acts as an incredible safeguard through early issue detection. By automating testing for every single code change, bugs are caught instantly, completely preventing costly production errors down the line. It also creates a continuous feedback loop. Developers get instant feedback from automated builds, which means lightning-fast issue resolution. On top of that, it dramatically enhances collaboration, unifying teams with synchronized workflows. And lastly, it boosts efficiency. CI optimizes things like cycle time and failure rates, meaning way fewer production incidents and a team that can actually focus on building great features. Let's see how this builds your toolkit. To adapt CI to your specific project, you have to find the right platforms, and developers love to debate which of these is the absolute best. Here are 5 of the big ones. We've got Jenkins, a hugely popular tool integrated deeply with version control. There's Travis CI, known as a really streamlined platform. Circle CI offers a fantastic cloud-based solution that supports multiple languages. GitLab CI/CD is a built-in automation powerhouse right within GitLab. And Bamboo is Atlassian's tool, which integrates perfectly with Jira and Bitbucket. Finding the right fit here is step 1 to turning your chaotic development process into a well-oiled machine. Section 3, the art of refactoring, fine-tuning the machine. Now, just because the engine runs doesn't mean it's clean, right? In Agile, teams have to maintain and enhance their code incrementally from sprint to sprint. This is where routine maintenance comes in. To really grasp this, let's look at how the experts define it. Joshua Kuryevsky simply calls refactoring a behavior-preserving transformation. I absolutely love that phrasing. It perfectly anchors the idea that we are actively changing the code, transforming it, but we are absolutely not changing its fundamental behavior or what it does for the end user. Now, what's really interesting here is Martin Fowler's specific focus on cost and understanding. He defines it as a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. This builds beautifully on that previous definition. Refactoring isn't just about neatness. It's about deep, lasting value. Making the code easier to grasp directly makes it cheaper and faster to modify in the future. Because here's the harsh reality. If you skip this maintenance from sprint to sprint, you are practically begging for poor code quality. You end up with unhealthy dependencies, duplicate code, and an overall landscape of absolute confusion and clutter. Refactoring is literally the only way to remove this chaos and simplify unclear, complex code so your project doesn't collapse under its own weight. Section 4. Overcoming developer friction. Seriously, why do developers avoid maintenance?
So if refactoring is so amazing for the software engine, why do teams actively resist doing it? Well, there are some very real roadblocks here. First is the time constraint. Agile sprints are time-boxed with strict deliverables, so carving out time to clean up code is tough. Then there's simple reluctance, that classic, if it ain't broke, don't fix it mindset. Developers also stress about integration with other branches, and there is a massive fear factor that changing things will accidentally introduce new bugs. I mean, we've all been there, dreading breaking something that already works. Plus, if automated test suites aren't set up, you face the retesting challenge. Nobody wants to do heavy manual testing. Finally, ensuring backward compatibility often stops refactoring dead in its tracks.
So the crucial point is balancing this fear against the massive relief. Yes, there's the dread of breaking existing working functionality, but look at the motivation. Refactoring helps everyone understand the codebase better. It makes it dramatically easier to add new code later on, and honestly, perhaps most importantly for developers' daily life, it just makes coding way less annoying. Which brings us to Section 5, the ultimate payoff. Why doing the hard work makes life easier. When you actually commit to refactoring in small steps, the advantages are undeniable. Think of it as the ultimate tune-up. It actively prevents defects from being introduced. It vastly improves software extendability, allowing you to scale smoothly. Because the code is cleaner, it significantly cuts down the expense of code maintenance. It gives your team standardized code, creating serious architecture improvements without ever impacting the software's behavior. Ultimately, it provides you with readable, modular components that are highly reusable. You're turning a fragile, cluttered system into a robust, extendable architecture. So, as we wrap up this explainer, I want to leave you with a final thought to take back to your own Agile projects. Knowing the chaos that happens when code is neglected, and knowing the incredible power of continuous integration and routine maintenance, will you let your code gather clutter, or will you refactor for the future? The choice and the ultimate performance of your software engine is entirely in your hands. Thanks for joining me, and happy coding!